Hello and welcome to COP 4708. This is a continuation for Chapter 2, Introduction to Structured Query Language. And we'll continue working on the database example, the Chapter 2 database example that we started with, learning about the SQL manipulation, DML language, the statement for manipulation, and how it works with the database that I already have. One of the things that we can use using where we can use like and some wildcards to play with the data and manipulate and query, especially if I don't know the exact information that I have in the database. For example, if I know the first name, I don't know the last name, then I can replace the last name with some kind of a symbol that will assist me in finding the information that I need. If I have some numbers that I'm missing, then I can replace them with some kind of a character or a symbol that will retrieve for me the information that I need. And this is what we call wildcards that can be used with the word like. Let's see how that works. So we'll go back to our database, the one that we started last time, and we go to create query design, close this, and SQL view. And we are going to search all columns. So I'm going to add the asterisk as a search for all columns from the SKU data table, where, and this is the condition, buyer like, and I'm putting the name because I know the first name, but I don't know the last name. Now remember, in the slides here, we said that we can use the characters, but what kind of characters? In the SQL 92 standard for server, for SQL Server and Oracle, we can use the percentage for any set of one or more character, while the dash for exactly one character. While in Microsoft Access, we can use the question mark for exactly one character and the asterisk for any set of one or more characters. So what I'm going to use here, since I'm using with Access over here, and I don't know the last name of that person, instead of using percentage, I will use the asterisk and close the small parentheses, then run my code, and I got Pete Hansen. Now remember that I did not know his last name. I knew that his first name is Pete, so I replaced the last name with an asterisk, or what we call a wildcard that can retrieve for me the information that's missing or that I don't know. Another example. What if I'm going to get information about the description of an item? SKU description, but I don't know what the description will be, except that I will be looking for tent. since I don't know what's before the word tenth and what's after the word tenth, then I can actually use asterisk before and asterisk after, and then run, and that will show me tenth here at the end, tenth in the middle. It has words after, words before. So whatever was in the description, actually it did show, and that's how I can use these wildcards. I can use them to display information that's missing, or that I have lack of information about. I don't know what to do. I don't know what are the description here that should be used, and that's why I'm using these wild cards. And I can use that also in numbers. And for the numbers, I will use the SKU column, which has numbers only. And I will say that the SKU like and with asterisk, because I don't know what's before the number 2. And then after the 2, I will put a question mark. And if I want, I can put like as many question mark as I want. So if I want to display 3 after the 2, then I can put 3. If I want to display 2 only, then I put 2 before or after the 2. So for the question mark, it will display one character only. So when I put 2, it will display only 2 characters or 2 numbers after the 2. If I'm using the asterisk symbol, then it will display everything before the 2. So I have to make sure how many numbers. So if I'm not sure, then I should use a wildcard that is more general and that can display more, like the asterisk. Let's do this example and see how this will work. So running this, it did show me the 100 before, which is 1, 2, 3 numbers. That's why I used the asterisk, because I didn't know how many numbers before the 2. But I knew that there are 2 numbers after the 2, so I used 2 question marks. There are also some built-in functions that I can use within the SQL. So instead of doing addition on a manual basis for the total order, total amount of order, I can do sum within the functions or the built-in functions that's in the SQL statements. For example, I can select the sum of extended price so I'm summing the extended price, but I don't have a column that is already existing or does exist in the database that can show or save the sum in. So what do I need to do in this situation? Actually, if the column is not there or is not being created, I can just add as and put order number 3000 sum, and that's a new column that I just created. So I am going to create a new column that's called order 3000 sum, and put under that the total amount of the extended price for that, the total amount of cost for the items that's been purchased under the order 3000, which is called the extended price. So this is going to be the sum for the items that's been purchased under order number 3000. Now, where am I getting this from? I will be getting that from that table that's called order item, where I have to make sure that the order number is equal to 3000. I'm just asking for the order number 3000. That's why I was specific or specified that in the conditions that I have here in the where. So this is my condition, this is my table, and this is what I need to do as a procedure, which is summing the information and displaying that in a new column that I just created. Once I'm ready, then all what I do is run, and it will display for me the total for these numbers, and that will show me the sum for order number 3000. Other functions that can be actually used, other built-in function, are the average, and let's do new one and call it item sum, and I will also calculate the average for the extended price, and I will save it as order item average. Then we'll calculate the minimum of the extended price, and we'll save it as order item minimum. Then we'll calculate the maximum, and that will be from the order item table. And actually I don't need any condition in this situation, just calculating all these extended price related functions, and we run, and we can find that the order item sum is 1180. The average is 168.57, the minimum is 50, and the maximum is 300. So it went through the table, added the items, got the average, got the minimum, and got the maximum for me in the extended price column. One of the things that you would like to do once you are in a database and you would like to query about the database, you will say, what's the size of the database that I'm dealing with? And this is one of the main questions that will come to your mind. Am I dealing with a huge database set or small set? How would I know? Actually, you can count the number of rows in a table. And to do that, all what you need to do is to use the word or the built-in function count. Now it will count it for me. When I use the word count, it's counting for me the number of rows. But although it's counting it for me, it will not show it. So to show it, I have to display it in a certain place. To display it in a certain place, then I have to display it on my screen as number of rows. And that will display it on the screen for me to know how many rows I'm dealing with. Once I run that, then it will give me the number of rows as 7. Also, I can be precise more. Well, where in this case, I'm just counting the rows no matter what I'm dealing with, but I can be specific about just the department. So within these rows, I'm looking for distinct department only. So, and remember the word distinct, that will be so precise, looking for just the name that you are interested in. And in this case, we are interested in the number of departments that I will be dealing with, and that will go within the table, search for the department. If the name is being repeated many times, actually it will not count that because they're counting the number of departments. So the water sports department will not be counted twice or 4 times. Actually, it will be counted 1 time because I have the word distinct, counting the departments that has a unique name, so 1 time only, not repeated. And then I will save it as department count. And that is in the SKU data table. Okay, so the word distinct department, actually it will not work with Microsoft Access, but it will work with SQL Server, it will work with Oracle, and you can actually check your book. I think it's page 61, I think. I'm not sure now, but check your book, and it says that this will not work with Microsoft Access. It says that this command, maybe it will not work with Microsoft Access, but I think it works with Oracle. You can try it with Oracle, you can try it with MySQL, and you can try it with SQL 2005 or 2008, and it should work. Can we do arithmetic calculation within the code? Actually, yes, we can, where we can have the quantity multiplied by the price, which is the extended price. So I will do it in a different way and compare the information that I have. So I would say quantity multiplied by price, and we're gonna save it as extended price EP. Then I will display on the side another column which is the extended price, and compare my results and see if it does arithmetic calculation and it does it right or not. Actually, this way I can make sure that the calculation that's being done by the extended price column or the function that I used is correct, and I don't have any mistakes. So this is another way to check on the columns to make sure that I have it. Now this is from order item. I'm just again, it's not a must to um, put the name in uppercase, but I would like to do that just to make sure that we are following standards, which is, if it's uppercase, all uppercase, then I know that I'm dealing with a table. If it's the initial letter, then I'm dealing with columns or fields. This is the column that's being calculated using the arithmetic calculation, and this is the one that's being calculated by the system, and you can compare both to make sure that you don't have any mistakes. So that shows you that the extended price that we calculated is the same as the one that's in the system. I can actually combine more than one column within a column. So I can say distinct right trim, and the reason I'm using right trim because I don't want to have any space on the right side of the word. So I'm trimming all the space that might be on the right side of the word that I will be using. In this case, I am looking for buyer. So I will trim the right side space that might be on the buyer. If it has blanks or spaces, then I'm trimming that. I will add the word in as is. Since I want to add it as is, then I will put between them a small parentheses that we've been using before, and then I will right trim the word department. Then I will save all this in a new column, or display it in a new column that's called as sponsor. And that will be from the SKU data table. Okay, let's see. Let's go to the code. And see run. Okay, so just by forgetting to put space here before the N and after the N, it didn't show at all. As you can see, this is what happened before. If you delete the space and run, the N word is gone and no space actually between the name and the department. So to add the N inside, I had to put space before and space after, then run, and now I have the name of the buyer in the department. So I got the word in and I got separation between the words. But what we did here, we combined two columns in one column and we called it sponsor. We can also group by and get all these information in one group or one category or two. It depends on what we need to do. For example, we can display department and buyer with counting the rows and also displaying that as department underscore buyer underscore SKU count, and that will be from the SKU data table, and then I will group them by department, then buyer. So what I did, I created or asked to display three columns or three fields, department and buyer, and the third field was counting the department as buyer, department buyer SKU count. So I'm asking how many buyers or how many times did that buyer buy from that department, and I'm saving that as a new column, a new field. So I have those three fields. I got the information from the SKU data table, and I'm grouping it by department and then by buyer. So the camping department, it will not be showing like 3 times or 4 times for the same buyer. Actually, it will be 1 time for each buyer. So let's run. And you will see that camping department is showing 1 time for Cindy Law, water sports is showing 1 time for Nancy Mayers, is showing 1 time for Pete Hansen, and the climbing is showing 1 time for Jerry Martin. So you see that Cindy bought twice based on this combination, bought twice from the camping. Jerry Martin bought twice from the climbing, Nancy bought twice from the water sport, and Pete Hansen bought twice from the water sport. So these are the kind of information that I was looking to display, and it did count for me the number of orders or times that this buyer bought from this department. we are dealing with many tables here. Can I ask the information to come from another table to from one table to another table and display all that in one column? Yes, we can. And this is what's called subqueries. So I can do a query within a query, and that's what's called subquery. To do multiple queries for multiple or query from multiple tables, we are going to create a query that will calculate the sum of the extended price and we are going to save it as revenue that will be from the order item table where the SKU in and within that condition I will write another statement that will select for me the SKU from the SKU underscore data table. And I will be more specific by adding another condition, which is a specific department that I'm looking for, and that is the water sports department. So what we did here, I made sure that I am bringing all the SKU numbers that is available in the SKU data table. So I'm making sure that I'm not adding any new SKU that does not exist actually in the SKU data table. Not only that, but I wanted for specific departments, so I chose the water sports here department just to make sure that I'm using the SKUs for the orders or for the items that's in the SKU data within a certain department to be included in the order item sum. Since the SKU actually exists in the order item table, then I will choose these certain values only to be added or summed and displayed as revenue. And this is called a subquery within the main query. Then we run and we got the revenue at 750. We can do it to be more complicated, and actually we can select a buyer from the SKU data table, and I can make more space for you to see how it's been written, where SQN, and then we select, and that's a sub query. The SKU from order item. So I'm selecting buyer, the buyer column from the SKU data, making sure that this SKU data is matching the SKU that is in order item, and the condition that actually the order number that I will be dealing with is in a new subquery that will go to the column called order number, that is in a third table, which is called retail order. And the condition that I'm looking for orders within the month of January only, and within a year, the year 2004. So I have a query within a query within a query. So I can do actually multiple subqueries within each other, going through 3 or 4 or more tables from the one existing here. I went through the SKU to order item to retail order, and got all the information from 3 and display it in one display, which is the buyer column. We run this and we got the buyer, which is, those are the buyers that bought items in January of 2004 with order number, certain order number, and from certain departments. I can also join information from 2 different tables. So I will go to select buyer and extended price. Now remember that the buyer in the SKU data table, which is fine, but the extended price from the order item. In this case, I have to make sure that the SKU data table, the SKU number in the SKU data table, is equal to the same SKU number in the order item table. And that will display for me 2 different columns from 2 different tables, the SKU data and the order item, and it will join or relate those SKUs based, or those two columns based on the SKUs from both tables. Now I can create a new one that will actually calculate the sum for me for the extended price and name it as buyer revenue with the same conditions, but I will add also that I would like it to be grouped by buyer, then order by buyer revenue and descending. So in this example, I joined functions, that the built-in functions that we have in the system, joining two columns from two different tables, getting the information that I need and displaying it in a new column, then making sure that the SKU data or the SKU number is the same within the two tables, with a condition that I'm grouping it by buyer and ordering it in a descending order when I display those results. There are no errors here. I don't see any misspellings or errors. Okay, so this one doesn't work with Access, but it works with SQL 2005, 2008. It works with Oracle, and it works with MySQL. So this is something related to Access database more than anything else. So this is not a normal error. This is a system or database management system error. But this should work with you if you have another database management system. Let's do another example where I will use and. Then I'll put the second condition here, which is order item I'm checking on the order number and making sure that the order number in both tables, the order item table and the retail order table, are the same. just making sure that the spelling here is correct and I didn't forget any words. Okay, I forgot to include the retail table as one of the tables that I need to explore to get this information. So we have to make sure that that's why when you are trying to use the same code and update it, you might have something wrong, but when you write it from scratch, you might not have the possibility of having something wrong will be less. When you are using the same code, you might forget something because you have a busy screen, busy code. So you just make sure that you are writing everything and you are including everything that you need. So in this case, actually, I'm not even summing. I'm not using the sum, but I need to display the buyer extended price and order month. I'm displaying 1, 2, 3 columns. The buyer from the SKU data, the extended price from the order item, and the order month from the retail order. And then those are the conditions. I'm making sure that the SKU number is the same between the SKU data table and the order item table. And I'm making sure that the order number is the same between the retail order and the order item tables. Now I will run and it will display for me the buyer, the extended price, and the month, which is a column from each um, uh, table, but at the same time they are joined together, they're related together. So actually Pete did spend 300, and that's the comparison here, or the mapping that we did here was through the SKU number and the order number. So I was matching certain numbers to make sure that those are the related rows or the related information to each record. So what's the difference between subqueries versus joins? What's the difference, and what are the advantages, disadvantages? Actually, they both process multiple tables. They both get you the information from multiple tables. But the subquery can only be used to retrieve data from the top table. So you are getting, although you have a condition from the condition in the subquery, but you are getting the information only from the top table. While in a join, in the join condition or the join command, actually you can display information from multiple tables, top or subquery, it doesn't matter, but you can get actual information from all included tables. We are going also to go over more subqueries, which is called correlated subqueries. That will be in chapter 7, and we'll talk more about creating the database itself in chapter 7. So with existing database, actually we can manipulate and explore the data, navigate through the data as we did, using some of the functions that's built in, or using some of the subqueries and joins and conditions based on the information that we have, and get the information that we need. But if I don't have the database being built yet, then I have to build it, and this is what we are going to do in chapter 7. That will be all for this session. If you have any questions, please email it. Thank you.